Finally here, let's take a look at users. With Hunter.io, this is going to give us information about the users, specifically the email addresses tied to a domain. With the free version, you're going to get a shorter list, and they're going to redact 2 digits, 2 characters from the email address. With the paid version, you get more information and you get the full email address. More importantly, to some degree, is we can get the username format. So I can get the format here. So for example, at SANS, they use the first initial and then the full last name. So if I'm trying to guess names, I could take every letter of the alphabet, or the more common ones, right? Skip X's and Z's, and then common last names, and build my own list of email addresses to guess for phishing or for password guessing attacks. There's also phonebook.cz that gives us domains, email addresses, the URLs. Be aware, though, that some of this is going to be old, right? There's an email address for an organization published online. But just because a user leaves an organization doesn't mean that that link, that email address, disappears from the internet. But it can give us names that are more likely to exist. One of the great things is publicly breached credentials. Not great for everybody else, great for me as the pen tester. But what happens is a user logs into some site. And this happened relatively recently, for example, at LinkedIn. So I'm going to pick on LinkedIn here. Let's say a user created an account on LinkedIn. They use their work email, which plenty of people do. I don't get it, but whatever. And then they end up using the same password as they do at work. Should you do this? Absolutely not. Do people do this? Absolutely. What happens then is, in this example, LinkedIn was compromised. Those password hashes were disclosed. Attackers cracked those passwords, figured out the password for that user, and then attempted to log into other services as that user, including services back at their company. Does this always work? No. Does it work sometimes? Absolutely. In fact, if you hear your friends and colleagues and family complain about their Netflix account being hacked or whatever it is, I'm going to bet probably my house that they used the same password there that they did on some other crappy website. It was compromised, and they reused the other credentials here. Right? We see this time and time again. There's a lot of places where we can get this information. Have I been pwned, dehashed? We actually use dehashed. The intelx.io is it's like just a dump of data. A lot of it's junk, some of it's good. Just kind of sift through it, sift through the garbage to find the good information there. There's public data dumps. So when these sites are compromised, it might be posted on Pastebin or some other location. I know a number of organizations that take that information, crack the passwords themselves, and then host that internally. And they use that to develop their own breach database. We can look at job postings. So look at a job postings, and from that we can get what software is in use, right? What technology, what hardware is in use. Because if they're looking for someone who's a SharePoint admin, guess what they're using inside that organization? SharePoint. Right? And you're not going to be able to redact that information because HR would be an HR nightmare. we're hiring for an unnamed IT person. Who the heck is going to apply for that? And also, what's the candidates that you're going to get? How do you match against that if you're not going to share that information? You have to put that out there to get effective matches for any openings. And we can learn information about the technology and the hardware used by that organization. What does the employee do? The great place for this, LinkedIn, right? It's the crappy Facebook for work. We can get names, roles, responsibilities, coworkers, sometimes a list of projects people have worked on or the technologies they've worked for, awards and accolades that they might have won. Now, LinkedIn doesn't want us scraping or extracting all this information because it's their proprietary information to some degree, right? It's what keeps them relevant. It's what makes them important. So they don't want our tools to grab all that information and extract it. So sometimes our tools break when they try to extract that because, again, LinkedIn isn't calling up the tools and say, hey, we're making a change here. Is that cool? Is that going to break your recon tool? They don't care. In fact, they would probably like to break that recon tool. And you can look other places as well. Twitter, Facebook, Instagram, God forbid, TikTok, who knows, whatever, then the next thing the kids are using these days. A great way to extract information from LinkedIn is with Gather Contacts. This is a Burp Suite extension written by Carrie Roberts. You import this into Burp. We do a LinkedIn, or sorry, a Google or a Bing search and click through the Google search and it extracts the information from Google. You're not even going to LinkedIn. We're using the Google or Bing search of LinkedIn, which is kind of neat. Downsides here, it doesn't give us email addresses, but we have people's names. And if we refer back to Hunter.io, we can get likely the email address based on the person's name. Right? Sometimes there might be out of date names where a person has moved on and hasn't updated their profile, but this should be quite accurate normally. Results can look something like this. Here's the example. We're searching linkedin.com/IN for a SANS Institute. And here is an example for 2 users. We see John Hubbard here and Owen, I'm gonna mess up that name. And Gather Contacts, as we click through Google, click next, 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 we'll extract the information from the page and then build a nice spreadsheet for us. So with that, we're gonna jump into yet another lab exercise. Here we're gonna jump into the lab exercise 1.3, reconnaissance. Again, if you have any questions during the lab exercise, don't forget, we've got 3 different ways for you to ask a question. The first, click the chat with us during office hours, have a live Q&A with our subject matter expert. You can click the Ask SME a Question button, or you can email online-sme@sans.org. So with that, let's begin the lab exercise. Welcome to lab exercise 1.3, reconnaissance and OSINT. So we're going to look through a few different organizations here, live, real organizations. And I tell you this because they're real organizations. They don't call me up and say, hey, Tim, we're making a change to our network. Is it okay? Will it mess up your lab exercise in any way, shape, or form? And I tell you this because most of the information that you're going to see here is going to match exactly what you see in the workbook. Some of it will change. We keep this very updated, but they might make a change on a Tuesday, so it might look just a little bit different. So just a heads up on that. These are live networks. Things will change. So just a heads up on some of these organizations that we're going to be taking a look at. Now, we're going to be first taking a look at Cliff Bar. Cliff Bar, if you aren't familiar with it, they make sort of healthier granola bar snacks kind of a thing. We're also going to look at Sands as well as another organization. We're just looking for the public information. This is not authorization to attack them. I couldn't authorize that even if I wanted to. But we're just going to look at the live and publicly available information for these various organizations. So we're going to start off with Cliff Bar, and I'm going to go to aaron.net here. Aaron is the registrar for North America, and I'm going to search here for Cliff Bar. Just a heads up here, the F, there's only one of them. There's not two. Now, when we do this search, it gives us, it's sort of like really bad Google. Like the results here are completely useless to me. What I need to do is click this search Aaron who is instead to get the information that I am looking for as a pen tester. And if we look here, we see two entities, and there are two different handles. We have this 1280. We also have 1359. Let's take a look first at the 1280. There's my handle once again. We've got a contact, and we've got an IPv6 network. IPv6, the networks are absolutely massive. We're going to talk more about IPv6 later in this course. But what we found here isn't tremendously useful. So click the back arrow, and let's take a look now at the second handle, 1359. If we look at this, we're going to see, once again, Cliff, I'm not even going to try to pronounce that last name. I feel like Cliff named the bars after himself. We also find a network range. So as part of our pen test, we may be tasked with identifying the target networks. Here, we have found one of those target networks. So we'll remember that range here for some of our next portions of our OSINT and reconnaissance. Let's open up a terminal window and let's use DNS Recon. We're going to look for the domain cliffbar.com, and we're going to use the name server here of 8888. So we'll let this run, and we're going to get some basic information DNS here. Let's take a look. Looks like they're using EasyDNS. EasyDNS is definitely not going to be in scope for our pen test. We've learned here that their mail server is PP hosted. So at the time of this recording, PP hosted is what they're using. This is Proofpoint. And the reason that that's interesting is it's important to know this information if we're doing any sort of phishing, because we have to get around those filters. What else? They're doing something with Google here. Probably have a Dropbox they're using internally. If we scroll down, we see these link addresses. This tells me very likely that they're using M365. And we're going to talk about Azure and Azure Tax in Book 5. Let's run that same command again here, but with the -W. So the -W is going to run our same command, but it's going to get the IP addresses, convert those IP addresses into IP blocks, and then ask us, should we run a whois lookup, that's what the W stands for, against those net blocks. One of the IP ranges is for easy DNS. Well, that's going to be out of scope, so no. Same with Cloudflare, Proofpoint, Amazon, and Microsoft. So of the IP addresses we found via DNS, none of those are going to be in scope for network-based attacks here. So right now, I'm just going to hit the N for none. I'm not actually going to perform that. Now remember, if we looked at Aaron, we did find a network. It just looks like, at least according to what we found in DNS, we didn't find any live systems in that particular range. What I can do, though, is I can use DNS Recon. Let me clear my screen. DNS Recon here. Once again, I'm going to specify my name server. I'm going to tell it to do a reverse lookup for that IP range. And I'm going to copy and paste because I don't want to get this wrong. And what we just tried to do is do a reverse lookup for every IP address in that range. And according to this, there were no results, which honestly these days is pretty common. We still want to test for it because we might find something. Again, in this case, no such luck. Let's go back to our browser now and let's take a look at DNS Dumpster. Now the colors here, unfortunately, are not ideal for reporting and screenshots because we end up getting gray on other gray. This is readable. It's going to get a little bit worse. I don't have any control over it again. So let's take a look now at sans.org. Give this a few seconds to run here. So first we can see that it looks like all the servers it knows about are in North America, which means if we're doing any sort of attacks as part of our pen test, we need to make sure that we're following the laws of, in this case, the United States. To the left here, we can see our IP block owners, and we see things like Amazon, Proofpoint, Google. If we get a little bit further over here, we do see some in the SANS Institute's IP block. So if we looked in Aaron and we tried to find SANS, we would find an IP block, and there are, according to the DNS lookups, 6 systems within that range. DNS servers looks like they're currently hosted on Amazon. Remember here, live network, things can and will change versus what I'm showing on the screen right now and what you are going to see on your systems. MX Records looks like they're currently using Proofpoint, once again, for any sort of phishing attacks. Again, please don't phish SANS. I am not authorizing that. We can look through, again, see some Dropbox, some other information here. We also see a lot of the A records. And what you want to do is look through this and think about what of these hosts might be the most interesting. Which of these hosts might have a login page, might have important or sensitive data, some way to authenticate. So let's take a quick look through this list. And again, this list will probably change. But if we scroll through here, we see an admin. That looks interesting. That's hosted by Encapsula. Encapsula is a DDoS prevention system. So my guess is, and I have no inside knowledge here, is it goes through the DDoS provider, prevention provider. They don't provide DDoS, that'd be silly. And then goes probably, again, just guessing, no idea, maybe back to a live SANS system. We see a lot of VPN hosts in the SANS block. This could be interesting if you were authorized for some password attacks. DevHQ could be maybe development sites. The interesting thing for development sites is realistically, they're probably not going to have real high value data, or like they shouldn't. but they also might not be quite as hardened. It could be test code that hasn't gone through the full vetting process. Scroll down, here's another admin system. And what you want to do is take a look through this list and again, think through the systems that might be a little bit more interesting if you were authorized to perform a pen test against SANS. Again, not authorized to do this. Next, what we're going to do is we're going to take a look at Shodan. So we'll take a look here at Shodan. And for this portion of the lab, you are going to have to create an account. You don't have to pay for a membership or anything. So I'm going to log in here. And we're going to take a look at 2 of the net blocks owned by SANS. If I take a look at this, we see no results found, right? We were just taking a look at SANS. I could do the same thing for another net block. Again, we could find this by looking at Aaron. It looks like at this time they have moved everything to the cloud. So what we're going to do now is take a look at another organization. This is the really boring named organization, the Service Provider Organization. So we'll take a look at their net block. And at the time of this recording, we can see a number of systems. We see systems listing on web ports, 443 here, 8080. This is a little bit more interesting. When we see an interface like this on the web, sometimes it's an admin portal type thing or something. It's definitely not a standard port. And if it's not a standard on the internet port, it oftentimes is a little bit more interesting. And it could be one of those cases where they accidentally exposed a service to the internet. We also see down here 502. 502 is Modbus. This is used by industrial control systems, ICS. You do not want to put Modbus on the internet. In fact, we can see here some of the data and interaction with Modbus here. This would, in my mind, be a finding that I would write up. This is not an internet-ready protocol, and more importantly, this just simply should not be exposed on the internet. Let's take a look now at hunter.io. Let's take a look at another organization this time. Let's change it up. I am a giant football fan, not of the Giants, but of the greatest team in the NFL, the Green Bay Packers. Probably gets some people who disagree. It's too bad that they're wrong. But if I type in packers.com here, see the nice logo a second ago, what I get here is, and if I had logged in with a paid account, which is cheap, I would actually get the full email address. What I'm looking for in this case is the email format. So I can see here, it looks like the format for these email addresses is the full last or family name, surname, followed by the first initial of their first name or their given name. And this is important. If I want to guess passwords, what I can do here is get common last names for the region of the world that I'm working. And then in this case, try maybe every single letter of the alphabet, or try the more common letters in the alphabet. I'm trying to guess some of these. So let's try sans.org. We see here, it looks like first initial, then their last name or their surname. Once again, if we're trying to guess some of those credentials, maybe email addresses for phishing, we need to know that format. Let's change it up now. Let's go back to Hyboxy. Hyboxy is going to be our target for the entire week here. So let's say during our test, we did some Googles, right? We did some searching for the target organization. Now, our target for the remainder of this course, as I mentioned, is Hyboxy. Hyboxy isn't a real company that's on the internet. So some of this earlier OSINT isn't going to work for this. But what we've done here is we've created a scenario where, let's say during our reconnaissance, during some Google searches, some search engine searches, we came across on digitaltrufflehogs.com, our simulated hacker forum here, that we found some information about this. I love it when my Twitter monitoring pays off. Mando Fan 87 just posted some usernames and passwords from two small tech companies. They even call them Hyboxy by name. Well, this could be interesting for us during our pen tests. We could take a look here at this Twitter account. We scroll down. It looks like, though, we don't see that missing tweet. In fact, the tweet we see, got advised to delete that previous tweet. I should have edited it, but Twitter Blue is pricey. So there was a tweet. We no longer see it. What we can do, though, is we can go to the Wayback Machine. So I'm going to go to archive.org. And I'm going to paste the URL for twitter.com/mandofan87. And if we look at that tweet is from January 11th, 2023. So let's take a look here. Let's click on this snapshot. Let's see if archive.org happens to have that tweet. Scroll down. And we can see here, it does. So it has a link to that tweet. The user deleted it, but archive.org did have that. So let's click on that link. So we see this. We can open link here in new tab. Mega here is a very common way where we see where either attackers post information or steal data, and they upload from the inside of the organization out to the internet. And what we found here is a list of usernames and passwords for this organization. So we found some breached credentials. So when we get into some of our password attacks later in this course, we probably want to try some of these passwords. So what I'm going to do here is select all of this, copy this, go back to my terminal, and I'm going to open up a text editor. Gedit helps if I type the right command. Paste this, save it, exit, and I can cat this file. And I'm saving this then for later. There's Webflix, not a real account. I don't think it's even a real domain. If someone buys it, it's out of scope. But this Hyboxy information is going to be interesting for us when we do some of our password attacks a little bit later. So that's going to wrap up the lab exercise. If you have questions during the office hours, you can click the chat with us to have a live interaction. You can click ask the SME a question or email online-sme@sans.org.